Hello, I'm Graham Lewis, and in this example we're going to solve a normal distribution problem and use the normal distribution to find a probability. So in a sample it was found that in Dutch men x bar is 184 centimeters, which is very tall, and the standard deviation is 8 centimeters. So we're going to use a normal distribution to find the probability that a Dutch man selected at random is greater than 187 centimeters tall. First thing you need to do, and this is aimed at AP statistics but will work in other syllabuses as well, is specify the distribution. So we're going to assume a normal distribution. So you can either write this in words, assume a normal distribution, because we've been told it's normally distributed, such that, and we're going to use the x bar as the population parameter. We're going to use that as an estimate for the actual population mean, 184 centimeters, and we're going to do sigma, we're going to use the S, the sample standard deviation, as an estimate for the population parameter, sigma, the standard deviation of the population. Another way of writing it, or you can say that you must define your variable, everyone must define the variable, so let h be the height of Dutch men in centimeters. So let h be the height of Dutch men in centimeters. So that must be in for everyone, defining your variable. And then you can say that h follows a normal distribution with a mean of 184 and a standard deviation of 8. So in AP statistics, this is the mean and this is the standard deviation. In other courses, they may give the variance. So they may say h follows a normal distribution with a mean of 184 and a variance of 8 squared. And they always give the variance as something squared if you're in one of those courses. If you're doing it the second way, this way, I would also recommend that you write down what mu and sigma are, just to be really, really clear so you know which ones you're doing. You're saying it's following a normal distribution, but just write down mu and sigma. So that's the first thing. So just in recap, you must define your variables, and then you must specify the distribution, either assuming it's a normal distribution here, that way, or writing it down with the notation. Okay, now let's go on to solving the problem. Always draw a picture. So I've drawn the normal distribution here, and I've marked on it the area I'm looking for above 187 centimeters. I've done a dotted line at the mean, 184 centimeters, and I've left it blank to put in my z-scores, which I'm going to calculate now. So always draw a picture. Now, when you're calculating the z-score, which we need, always write down the formula. So I'm going to use x minus mu over sigma, and then obviously the x I'm interested in is the 187. That's my particular x. My mean is 184 and my sigma is 8. And if you calculate that, you get 0.375, of course, because it's, of course, 3/8, which I should know. So therefore, you've got now the z-score of 0.375. Remember to show the formula, show you're working out, and then do the number here. Now, I like to round my z-scores to 0.38 because if you're using tables, they're always rounded to 2 decimal places. But if you're using your calculator, you can leave it as 0.375, but don't round to less than 2 decimal places. So my z-score here is 0.38. So now I'm going to show you how to use it using tables, and there are 2 ways. Now, of course, the tables tell you the cumulative frequency up to, from minus infinity, up to the value. So if I look up the z-score tables, it will tell me the area I don't want, and that's fine. So what I can do is find the area I don't want using tables. So I'm looking for a z-score of 0.38, and let's do that. Now, all of the z-score tables I've seen, the majority of them all work in telling the area from minus infinity up to a value. So the area from minus infinity all the way up to a value. They don't tell you from right upwards. So these are the z values here and here. So for example, 0.30, so left of 0.30 would have an area of 0.6179. Left of 0.31 would have an area of 0.6217. Left of 0.32 would have an area of 0.6255. But of course we're looking for 0.38. So if we look, we've got 0.3, that's the row we want, and add the 0.08. So go down the column and across the row until you get the z-score you need. And so a z-score of 0.38 is there, 0.648. And I'll pause there. That's our area. So the inside, the z-scores are on the columns and the titles, and the black numbers in the middle are the probabilities, the area. So 0.648. So I now know that the area from minus infinity all the way up to 0.38 is actually 0.648 from my tables. So now I can actually finish this problem. So I want to find the probability and do it in terms of h's. I want h bigger than, if we remember, 187 centimeters. So I want the area bigger than 187 centimeters, and that's the same as the probability standard distribution of z being bigger than 0.38. Now, I know that this white area here is the area that I want, but I know that everything adds up to 100% because it's a probability distribution function. So therefore, I just subtract my 0.648 from 1. And if I'm showing the working, which I think you should, it's 1 minus the probability of z is smaller than 0.38. So the area I want is 1 minus the 0.648, the area I don't want. And then I'm going to put 1 minus 0.648, and it's important here to say where you get it from. So did you use your TI calculator or another calculator, or did you use tables? So I'm going to write from tables. Don't forget to always write where you get this number from. So I got it from tables. And if you used your calculator, you can write from your calculator. And from there, you can write down the answer. And there we have it. We get the answer 0.352. We turn that into a percentage, and don't forget to finish off with a sentence in context. So approximately 35% of Dutch men are taller than 187 centimeters. I'd now like to show you another way of doing this. So here we wanted to find the area above 0.38, and I used the fact that that's 1 minus the area we want. Here's maybe a slightly easier way if you're using tables. So we know that the normal distribution is actually symmetrical. So here's my mean, and I want to find the area above 0.38, and that has to be identical to the area below minus a z-score of minus 0.38. So instead of doing the 1 minus the area you don't want, you can say the probability, again, start with h. H was bigger, I think it was 187, wasn't it? Yeah, 187 centimeters. H is bigger than 187 centimeters is the same as z being bigger than 0.38, which is the same as z is being smaller than negative 0.38 by symmetry, and then we can go back to our z-score table. So here we go. Now we want to find a z-score of negative 0.38. So here's my negative 0.3. Here's my 0.8. So if I go across the row and down the column, I'll go just like that. I get my answer there, giving me the same answer before of an area of 0.352. And so I get the same conclusion, approximately 35%. Thank you very much for watching. I hope this video helped. Don't forget that you need to define your variable, specify the distribution, show all your working, draw a picture, and write in context. Enjoy statistics. Thank you very much.